Thank you, Sai. Okay, get all my two-handed, two-fisted talk here tonight. And I'm going to try out all the parts here first. So I want to first acknowledge 3 of my graduate students who did most of the research on this project, the 2 projects I'll be talking about here. Alyssa and Brian worked on the Elwha River, and Chandler worked on the Naches River dam removal. And then we have some of the organizations that supported, oops, good thing it doesn't go that way. Okay, here we go. Some of the organizations that supported this research. So 2 dam removals in Washington State. At first glance, they look pretty different. The enormous, tall dam on the Elwha River in western Washington, out on the Olympic Peninsula, and then some of you probably recognize the Nelson Dam here on the Naches River. So I'm going to be looking at what was the effect of these dam removals on the river itself, and then I'm not going to focus as much on the fish. I heard that you heard about fish last week more, but obviously the river has a big effect on the wildlife and the habitats and the creatures that live in and around the river. So let's get going here. Okay, so Glines Canyon Dam on the Elwha River. It's tall and narrow. It was the tallest ever dam removal at that point in U.S. history. The Klamath River dam removals that just happened in the last couple years are, in terms of the volume of dam, bigger, but this one I think was still taller than the tallest of those. And then, whoa, how can you compare this? You know, Nelson Dam, okay, it's not nearly as tall. It's, but there are some similarities. There's similarities and differences, and we'll go over those as we progress through these 2. But I wanted to show the Elwha first because it just gets so much news and it's really exciting. And, you know, it was pretty exciting. But the local dam removal, as we'll get to in the end, or the second part, is maybe in some ways has a bigger impact because there are a lot more of these smaller dams around the country than there are the really big splashy ones. Okay, so here we go, the Elwha River, the Elwha Glines Canyon Dam being removed in real time. No, in sped up time there. So I don't know if you missed that. You're going to get another chance in a minute for a slightly different view. But before we go on, I just want to mention some of the important things with this. Okay, they took it down incrementally. So this black line is basically the dam elevation going down over time. It actually started a year before this, but the first year, the dam was just going down through the water, the pool of water in the reservoir. So for us, as far as the river is concerned and the impacts on the river, things really started happening when the dam removal first intersected this big pile of sediment that had been accumulating behind the dam for 80 years. Sediment and large trees, large logs, wood. So keep that in mind as we go forward. And then they took it down incrementally over the next 2 years after that. So overall, it took 3 years for removing this dam. And there was another one farther downstream. I didn't work on that one, so I'm going to focus on the Glines Canyon Dam. I have another video. I'm not sure if it's going to start automatically or not. Oh, no. Okay. We got a little rest here. The video's on the next one. So had this big reservoir behind it that stored a lot of sediment, fine sediment and wood. So this dam did not pass sediment or wood over it. All of it stayed behind. Only water came over. What we looked at, I'll go into this in a little more detail later, but this is a view of a section of the river downstream of the dam. And in here, red are areas that eroded, and blue are areas where there was sediment deposition. So I'm going to cover that a little bit more in a couple of slides. And once that river was free to start doing things and moving around and kind of acting more like a natural river, it went back and forth and did all sorts of stuff. So here's the road that, I don't know if any of you've been out there, but there's a road that used to go up the Elwha River. And several years after the dam removal, and for them trying to put temporary bridges over, they finally just gave up. And now the road no longer goes up there. But you can walk around this washed out part, and you can even wheel your bicycle around, and then you get this beautiful paved road all to yourself if you get upstream of that. Okay, so let's look at, so this is a different view, and you're going to see the reservoir going down, and you'll see the river starting to, here it comes, it's starting to prograde or like move forward into that lake. It's making a delta in the lake, shrinking. Okay, and now we get to the point the lake's gone, the reservoir. The dam's still being removed off screen here. And you can see, okay, not much happening here, but keep your eyes on it. See how the river's just going back and forth in that former reservoir lake sediment. And their plan with this was to allow the river to take that out naturally. Whoa, big storm event happened there, and it kind of did a big jog to the left. We did a survey out there and lost one of our tripods because I had put it 40 feet away from the edge of the river one evening, and we went back the next day, we couldn't find it because in that one night, because the sediment is so loose, the river had actually migrated laterally and took our tripod out. But we saw it later, this orange thing sticking out of a gravel bar in the middle of the river, and we're able to go out and retrieve it. Okay, so that's the excitement on the Elwha, and then just a little bit of what we did. Oh, I'm supposed to stand over here, sorry, in the camera. So this was Brian's project. We picked 4 sites downstream of the dam. So here's the dam at the bottom, and the river is flowing to the north. So 4 sites downstream. And then we looked during the dam removal time period at how those sites, how the river changed in those sites over that time period, three years in this case. And then later, almost 10 years later, my other student, Alyssa, came back and looked at what were the longer term effects. So we'll just summarize briefly here. What did they find out? So if we look over here, this is before the dam was taken out, before the sediment was released anyway. And it's pretty coarse gravel here. And that's because when the river just didn't have the power, when all that was coming over the dam was water, it didn't have the tools to move back and forth, which is what allows it to pick up sediment and move it somewhere else. So it's called an armored channel, meaning you've got gravel across the channel bed and it's too big for the river to actually move it. So it moves the finer stuff like sand and silt through, and then it just stays in one place. It's got an armor on it, and that causes the river to get kind of locked in place. And that actually happened also on the Naches River. We'll get to a little later. Then we've got here, during the same site, this is all the same site. So during the middle of the dam removal, you can see that a lot of fine sediment has filled in between some of these pieces of gravel. And that happened not only in between the gravel, but in some places whole new sandbars or gravel bars formed. So you get a new gravel bar forming where there used to be river channel, it pushes the river over. Well, that means the river starts eroding in a new place. Oh, now it's introduced new sediment in, or new wood falls in, and that makes the river kind of push over the other way. And so once you get that process started, the river starts going back and forth, establishing new paths and making in some cases, multiple channels and more complex river system, more complex habitats. So after, down here, we've got, in this case, sort of a finer mix of sediment than we had before. So it's not fine, it's not coarse, it's like Goldilocks, it's an in-between. And that's shown over here. So the way to read these graphs, I'll show a few of them. We have the sediment size here, and this is the percent, but don't worry so much about that. What I want you to remember here is if the line is farther over to the right, it means it's bigger sediment, coarser sediment. And if it gets farther to the left, it's fine, like sand or silt. So before, here's where our graph is. Over to the right, that's this. It's big gravel. During, it gets pushed way over to the fine end because it's this blanket of all that sand that used to be behind the dam got spread out downstream on the river. It basically covered up a lot of those old gravel bars, but it didn't necessarily move them right away. And then Alyssa's surveys several years later, 8 years after, it's kind of reestablished in the middles between those two extremes. So it's really kind of a Goldilocks situation. The river has, and that's because it's been able to start mixing that old sediment and the new sediment and come up with a size that is actually appropriate for the river to move and use and shift its channel around naturally. Okay, I should say, let's see what we're going to, okay. So these are some of those types of graphs that I showed or earlier, maps. The red dot simply means that's the same, it's marking the same place in both images. It doesn't mean anything other than that. And these are pictures of that site from a bridge that I'm standing on. And did I just turn this off? Okay. And they show what happened. So this was before the dam was removed. And this is during, and you can see, whoa, this whole channel on this side totally filled up with fine gravel, sand and gravel that came from the dam, pushed the river over to the left. And what I don't have a picture of here was there used to be a campground here called the Altair Campground. This is in the Olympic National Park. There was a campground, and I camped in it when we were doing our field work out here. And we were camped like 2 rows back from the river, you know, rows of campsites. And by the end of our project, oh, and the bathroom was behind our campsite, and then there was another row. So I think there were like 3 rows of campsites. And by the time we finished, the bathrooms were on the bank of the river. And the first 2 rows were gone. Our campsite that we had camped in was no longer there. So the river did, again, what rivers do naturally, it started moving over to the left over here after, so all this green stuff is the deposition of this gravel here. So things went kind of crazy there. So another big element with the Elwha Dam removal that was not the case over here is the large wood. So the Olympic Peninsula, how many people have been out there? Yeah, there are a lot of trees out there. Well, 80 years, just imagine 80 years of trees that have fallen into the river upstream that got trapped behind the dam, and they're mixed in with the sediment on the bottom of the reservoir, kind of waterlogged. They all get released within a couple of years, and those big logs just got strewn along the channel initially. So this is before. There are those red little dashes are individual logs. There are not very many of them. So the only way for the river to get logs in it before the dam was removed was from trees that just fell down right there along that stretch. There weren't ones being brought in from upstream. Okay, initially then, a whole bunch of individual logs came washing down when the dam was taken out, and then they started gathering together as they were being pushed around by the river, and that's the blue. So the blue are log jams, multiple logs piling up together. And you can see by the end of this series in 2020, you've got, a lot more, well, way more. So over here, there's only 2 of very small log jams in 2012. And by the time we get over here to 2020, it's mostly log jams, or there may be half and half log jams and individual logs. So this is down in the lower part. This August, after dam removal, August 2014, is what one of these log jams looks like. So here's the same site, 2012, not a log, nary a log in view. And this is what it looks like 2 years later when there's a big accumulation. So you can imagine then that these logs also served to push the river around. So you've got sediment deposited, you have log jams. The log jams are actually growing bigger and kind of stabilizing, and then that's caused the river to split or to move around, and it introduces a lot more complexity in the channel response to the dam removal. So here's just a graph summarizing Brian's and Alyssa's work, and let's just look at a couple of the main points here. So if we go over to these graphs, start with the ones on the bottom, the channel sinuosity and the braiding index. Sinuosity is just a measure of how curly, how circuitous is the route that the channel took. And the braiding is an index of whether it's a single channel would have a braiding index of 1. And so it's a measurement of how many threads there are to this river channel. And you can see leading up to the dam removal, so that's the dashed vertical lines. We didn't have a lot of images to work with, but the ones we did have showed that it kind of stayed the same, okay? It was, there was not a lot of sinuosity or braiding and not a lot of change. You could raft it then. Well, that's one of the things that didn't really survive the dam removal process simply because there's so many log jams and things now. It's not great for rafting anymore. But it was, I guess. I never did it, but it's a beautiful area and it would be fun. So these vertical lines are the dam removal, and you can see when the sediment started being released. That's the middle line. Whoa, that braiding index shot up. So did the sinuosity. And look at the logs up at the top. Like, oh, this huge number of logs coming in. And then some of those things kind of eased off a bit. So that's something to think about if we think about what's happened on the Naches River or what might happen in the future, because that dam removal is much more recent. It was 10 years after this one. So one of the things we've found here is you got this big spike of stuff happening right away, but then, for example, the braiding index, that kind of went back down and it settled at a new number higher than it was before, but it's not fluctuating as much anymore. The sinuosity, that's the curviness, that kind of continued to go up, and maybe now it's going down. It looks like that hasn't really reached a new complete equilibrium yet at the time that we did this study. And the log jams are kind of interesting because the number of logs has sort of gone down and maybe even decreased a little toward the modern day, but it's not like they're leaving the system. They're just getting grouped up into larger log jams. So the number of individual logs that we mapped went down, but you can see that the area of the log jams continued to go up. So they're basically just getting collected and making bigger and bigger log jams that will probably be there for a longer period of time. So that's, I think, kind of the Elwha story. Yeah, that was our summary. And I should say down here at the bottom, the river, in this case, is free to move around. It's in a national park. So they tried, to keep that road open. And finally, they're just like, okay, river wins. We're going to let it move back and forth and do its thing. And a little bit about the fish. So a lot of this dam removal was driven by fish habitat because it did not have fish passage, neither of the dams. So there were 2 dams. They didn't have fish passage. And I think the fish were there like knocking on the door for this to be taken out because they reoccupied immediately after the dam was removed. Well, not immediately. So just a little bitty side thing. One of the people who was really involved with this, Andy Ritchie, he was scheduled to come give a talk about it in 2015 at Central Washington University in our department. And he contacted us. He's like, I have to postpone because there's this giant boulder. Once they took the whole dam out, all the concrete, they realized there was this huge boulder at the bottom of the canyon where the dam had been, and it was still blocking fish passage. But because of the way the contract was written, the people removing the dam did not have a contract to move the boulder. So there was like this concern, oh, maybe we did all this, but now we've got this giant boulder there. And Andy looked up the plans for when they built the powerhouse for the dam and looked at these old air photos and determined that people had actually knocked this boulder in when they were building the powerhouse, which means it wasn't natural, which means that the park could blow it up. So the day they were supposed to blow it up was the day he was giving his talk here. So he's like, I really want to be there when they dynamite the boulder. So he postponed his talk, they dynamited the boulder, and now fish can get up there. Okay, so let's look at our dam here. What about the effects of removing small dams? Like, how do they compare with this big, exciting dam removal that we looked at? And my student Chandler worked on looking at the effects of removing, oops, not at that part yet, removing the Nelson Dam on the Naches River. So some of you probably remember that. This is right where Highway 12 crosses the river, and it was immediately upstream of there. And a whole consortium of groups worked together to not just remove the dam, but replace it with an engineered channel, roughened channel that continues to have some of the same functions that the dam did. So they wanted to continue to have irrigation, diversion, they wanted better fish passage, they wanted flood control upstream. So there was a multi-purpose project, and not just let's, take out this dam and see what happens. It was a very planned project. Okay, so this part, if we did it right, you will not be blasted out by really loud music. So if you hear faint music, that's intentional. Don't feel like you're missing out on something. And I'm just going to show the first part of this drone flight through the reconstructed channel. But if you want the full experience, you can scan that QR code and you can blast it at home and, rock out to the music. Okay, so we're going to try to get this. It's on a YouTube, so I have to go to another site here. Okay, that part worked. I think I have to put this. Oh, okay, so it's not too bad. Whoops, but now I lost it. I'm going to try to get it full here. You might get tired of this music after a while, though. So this is where the dam used to be. And then he's going to fly up through this reconstructed floodplain. So part of this was they built a new levee set back from the river, you can see on the right here, and a couple of pilot channels. I have not been out there since the floods last December. So I'm pretty interested to see what happened out there during that event. Planted a bunch of new vegetation. Well, you can read what he wrote on there as well as I can. So we're going upstream here now. I think we're going to come down. Yeah, so here's the other pilot channel. They put intentionally some large wood in there. But it just means a channel that they'd like the water to go down. So they're kind of saying, hey, when there's a big flood, please come down this way. It's dry most of the time, right? And until this year, I don't think that North Channel had water flowing down it since this project was put into place. Okay, there's the bridge that I'm sure you've gone over, and see how the channel, the water's a lot rougher in this part, more ripply, and this is probably a good place to stop. That's because they put some larger boulders down in there. Oh, I don't know if we want to keep. It's kind of fun to watch, so it's not that long. But if he starts going back up the same place, we'll stop it. So it's a very complex project. Yeah, I think we're kind of going back up where we already went here. So I'm going to try to. There's the pilot channel. Okay. Oh, you're going to help me here? We can just close it. Okay, that's good. Yeah. Awesome. Thank you. So that was put together by Yakima County, giving an overview of the project. Now, let's look at what this one did to the channel. So this is the same thing we just saw, but this is over here before some of the situations that from just not a very big dam, 8 feet tall, but you had sediment. It allowed sediment over the top because it actually filled up to the top with sediment. So gravel could get over, but it was basically putting this 8-foot wall in the channel. So you had a wedge of sediment that accumulated upstream for a couple miles. And that at times, according to Yakima County, caused some flooding because you'd basically filled the channel up higher than it would have been naturally, and then a relatively small flood could overtop the old levee and get into areas along the sides where you didn't want it. The fish passage was not great. It apparently filled up with gravel periodically. So you had this big wide channel upstream that occasionally had flooding, but downstream you had an armored channel similar to the Elwha, where there was large gravel on the channel bottom that was too big for the river to pick up and move on a regular basis. So that's a before, and then here's right after they put this reconstructed channel in that we just saw in the video. So some of the things that they're trying to alleviate is alleviate the flooding here by building a setback levee, allowing sediment to go downstream. Oh man, I really went back there. There we go. But still allowing the diversion. So this is a complex challenge to keep all these different things going. So we were looked at how will it affect, or how did it affect the channel geomorphology? Well, this is still a case, this is still ongoing. We don't know the total answer yet. So I brought a bunch of students down there many times in classes, in summer. A lot of undergraduates from Central Washington University went back and forth across these gravel bars measuring sediment. And we were trying to figure out how much, where's the sediment going, how much is moving, where's the channel eroding and depositing. So the different things we worked on, mapping, sediment surveys. Let's get into some of the results here. So These graphs are similar to what you just looked at with the Elwha River over time. And you can see I didn't have a lot of photos prior to the mid-90s, but probably not a lot of changes. So there's a similarity. Even with this small dam, it's kind of impeding, especially downstream, changes in that river channel. Here's the dam removal. It only happened between 2021 and 23. So we're still in the recent days here. We really don't know yet what the full effects of this Nelson Dam removal will be. And part of that reason is down here. So here's our dam removal in the dark line. And here's our peak spring flow in the years following the dam removal. So until this year, it just so happened that was a series of not very big flows coming down the river. And no matter what you do to the channel, if you don't have water flowing down it, things are not going to move. So it's all set up for things to happen, but you have to wait till there's a bigger flow. Okay, here's this year. So there's our flood in December 2025. And I know a lot of you all of you are very familiar with that event. So that's pretty big, but because it's been wintertime and the river levels are still fairly high, we can't really get out there until next summer at low flow to see what the effects have been on the river channel. So we're still waiting to see what happened to our particular study sites. In this case, though, here's our dam removal. Maybe we had a little change downstream, but you had the opposite change upstream. I think possibly more braiding upstream. That could be due more to the levee setback, but I think it's still early days there. And that's one of the differences, I think, between removing a small dam like on the Naches River and the large Elwha River Dam. That Elwha River Dam, it had all that sediment and wood that was ammunition to just start shifting the channel around downstream. With these smaller dams, it may take longer. You may have to wait till you have some bigger flows because you're not going to get this enormous pulse of sediment immediately. So you've got to be maybe more patient. But my feelings from the what we've seen initially is that probably you will end up with similar results. It just might not happen in the first year or the second year or even the third year. You might have to wait until this year that's just happened to really see the whole new system in operation. So here's some of these graphs again, and there are a lot of lines on here, and I'm just going to draw your attention to a few points. So one is that blue is sediment sizes upstream of the former dam, and the red and orange and yellow are downstream. Okay, so let's move down to this one where they're together. This is in 2024, so 2 years ago. Downstream remained coarser, because remember, coarse is to the right. So the sediment downstream of the dam was coarser than upstream. And that's been pretty much the case since an earlier study that we didn't do, but that was done when there was a survey of the Naches River commissioned by, I think, by Yakima County. They found that this dotted line is the sediment downstream, the blue line is upstream. So there's been this difference, coarser armored sediment downstream of the dam, finer upstream, and that seems to have persisted for about at least last 10 years, probably longer than that. Okay, now we're going to look at the one data point we have from last summer. So as I said, we haven't gone out there yet since the big floods in December. But if we look at this, 2 of these red sites. Whoops. So remember, those are the downstream ones in our surveys have moved to the left. So they're actually getting similar in their sort of Goldilocks sediment composition to the upstream ones. And that's what we want to see in a river restoration, because it means the river's now starting to become capable of moving this coarser sediment around that it hadn't moved when the dam was in place. So as I said, you may just have to be more patient with seeing the effects of these smaller dam removals, but it's kind of moving in the right direction. These two sites that moved over here, you see the other ones are still stubbornly over in the coarser part. The two that moved to the left were in sites that were either the first one downstream of the dam, or it was a pile of new gravel that had been deposited against one of the former sites. They're both kind of closer to the dam. The farther away ones haven't really changed yet. So that was 4 years after the dam removal. We're just starting to see some changes downstream. Now I'm going to take you through a series here of these red-blue changes in the river. Red is erosion, blue is deposition. We were so fortunate on the Naches River that Yakima County had acquired LIDAR imagery, so it's basically aerial imagery of the river, since starting in 2008, every few years. This is a remarkable data set. Most places don't have this to work with. So we were able to say, okay, what happened during this, over 10 years prior to the dam removal? It kind of sets a baseline, and then we can compare the after dam removal to that baseline. So we're going to just kind of go through this. This is just an example. This is not from the Naches River, but we'll start with this one. Okay, so this is the first match. It's subtracting 1 year from the other. Okay, so it goes back actually to 2000, not 2008. So this is a comparison of 2005 to 2008. We had erosion. This is just the upstream. And the next pair of years, the next pair of years, the next one, and then the final one is before and after the dam. So if we go back through these, I don't know about you, but there's not like a super consistent pattern. It's like some years there's deposition, some years there's erosion. Okay, so that's the upstream. Now we'll look at the downstream. So it was our early pair of years, a lot of red. There was a lot of erosion in those 5 years. Oh, but the next 3 years we saw deposition. And then we saw kind of in between. And just want to point out one thing here. This is kind of an interesting area where the red indicates that the river's been moving sideways. It's eroding the bank there. And that's before and after the dam removal. So again, downstream, maybe there's been a little more erosion than deposition, but not a super strong pattern. This is for both upstream and downstream in the years spanning the dam removal. So it was like, oh, okay, we wanted to see like some really dramatic change. Oh, a bunch of sediments eroded from upstream and it's gone to downstream. But no, they both got deposition, as it turns out. So as far as the immediate effect, it was pretty minimal compared to the big dam removal out on the Elwha. But that's not quite the end of the story yet. A little bit more on bank erosion. So this is something people have been interested in. And basically, we didn't see a big surge in bank erosion from the dam removal. So some people saw that as a positive. Again, I think we just need a few more years of data to see what really happens, especially this year. But here's something that I want you to keep in mind, that if one of the goals of these restoration projects is that you want to see more complex habitat and you want to see multi-threaded channels, that involves some kind of erosion. Like the rivers have to pick up that sediment from somewhere and move it somewhere else. And we'll get back to this at the end and maybe in questions, but it's a big challenge for restoration, especially in an urban area, an urban environment like this, because you do have to balance, oh, we want this wild, messy river. That's, well, a lot of people talk about, that's going all over and it's got multi channels. But wait a minute, we have, over 100 years of people who have established infrastructure along rivers. I mean, this river, it goes through Yakima. It's an urban river, but then you think of rivers like the Mississippi River in New Orleans, So it's not a simple question of let the rivers run wild where they want to go, like maybe it can be in a national park like the Elwha. There are multi-stakeholders and multiple uses and all these things for the challenging work of the planners. I'm just the geologist who goes out and says, this is what rivers would do if you do this to them. But the real challenge comes in with the people who take that information and then implement it in a way that is constructive and reasonable for their community and for the habitat, for all the multiple factors involved. So these are a couple photos from the floods that happened in December 2025 along the Naches. Now, I want to make a really major point here. I don't want anyone to think this is the result of the project that we've been talking about. It's not. It's farther upstream. But I think it's an example of kind of how rivers operate. They move. Naturally, the Naches River moved back and forth across the floodplain, across the valley bottom. Now we have Highway 12 going along it, and it's like, oh, okay, what are we going to do in these areas where we have highway or houses or other uses next to a river? As I said, this is where the real challenge comes for the people who are actually implementing plans here. I think the plan that was implemented at the Nelson Dam had a lot of forethought, and so I don't want anybody to get the idea that, oh, that was a bad plan or it caused erosion. That's not the case. Okay, so let's wrap up here. The big dam on the Elwha River, rapid release of sediment and wood. There was immediate channel changes. They were dramatic. They went all over the place, big log jams. It washed out roads. And then it kind of decreased in the decade or so after that. It's still moving. The Nelson Dam on the Naches River may be more of a delayed response, but 4 years later, it's starting to show some changes in the area where, downstream in particular, of where the dam was. I think for these smaller dam removals, it's the change is really dependent on the timing of the large flows. You just have to wait for there to be water that actually moves things around. And then the last couple points here. Okay, maybe the small dam removals, those channel changes are more gradual, but these are much more common. We have a lot more 8-foot tall dams around our country than we have 80-foot tall dams. And so, taken together, perhaps these have a bigger collective input, and certainly they have a lot of local effects on communities and on natural habitats. And then just a reminder that a restoration of a natural channel with complex habitats does involve both erosion and deposition. And that's just something that has to be planned for as we see more of these dam removals in the future as means of trying to restore natural channels. and a need to balance priorities. So there's a beautiful view of the Naches River, and I will entertain any questions.